Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today we are going to discuss about peripheral and interfaces. So what are the peripherals that can be interfaced with the microprocessor like an 8085 or 8086? So first we are going to discuss about 8253 programmable interval timer. So we can take this 8253 and 8254. So there is a small variation only available between these two. So both are the timers. So the difference is, look at this 8253, the operating frequency is 0 to 2.6 megahertz, but this 8254 it operates from 0 to 10 megahertz. In 8253 it uses NMOS technologies, in 8254 it uses the HMOS technologies. Again 8253 we have this read back command not available, but in 8254 we have this read back command available. That means, so whenever we need to read that command write command, we can use these options. Again, read and write at the same counter cannot be interleaved. But in 8254, the read and write can be the same counter can be interleaved. So this is the main difference between 8253 and 8254. Remaining control words, block diagram, operations, all the things will be similar things. So 8254 is a small updated version of 8253. Look at this block diagram of 8253. So we have this data bus buffer, this is the first block. Again we have this read-write logic and control word registers. This side we have this counters, counter 0, counter 1 and counter 2. So this is an internal bus that will be connected to all the blocks. So look at this first one, data bus buffer. So 8-bit data bus bidirectional bus will be connected between this data bus buffer and this microprocessor. So 8-bit D0 to D7 that will be considered. So this D0 to D7 that will be connected to this data bus buffer. So whatever the data writing to this 8253 or whatever the data reading from this internal bus to 82 microprocessor, so that will be available in this data bus buffer. This is a bidirectional 8-bit data bus buffer. So it connects internal bus with the microprocessor. Look at this read write control logic. So this generates the required control signals and also it take care of the operations. Look at this, what are the signals will be connected. So read bar, write bar, this is an active low signal. That means whenever we give 0, this signal will be activated. That means this is RD is a read signal, WR is a write signal. Whenever this RD bar is 0, read operation will be performed. Similarly, whenever WR, that is a write bar is 0, that write operation will be performed. So read bar or write bar, any one should be 0, that corresponding operation will be performed. Look at this is A0 and A1. So this will be used for an address bus. So A0 and A1 we have a 2 bits. So 2 bits we have a 4 combination 0 0 0 1 1 0 and 1. Depending upon this, so counter 0, counter 1, counter 2 and control register will be selected. Because whenever you are writing some data, so whether you are going to write it for a particular counter or a control register, so that should be selected by these two address lines A0 and A1. So this is chip select line, it enables the overall chip enable. So remaining all address lines, that is an A2 to A15, all the lines will be connected to this chip select pin through some logic gates. Depending upon that, the address will be varies. Look at this is the control register. So control register will be used for that operation. So which counter is selected, which mode of operation is selected. So that data will be returned to this control register. So based on that control register value, that particular counter operation will be selected. So we have these 3 counters, counter 0, counter 1 and counter 2, all are 16-bit counters. So actually we can use it this is as a counter or timer, both will be possible. Whenever it counts external clock pulses, then it will be called as a counter. Whenever it counts internal clock pulses, then it will be called as timer. So we have a 3 timer bar counter 16-bit, each will be 16-bit. So we can use 3 at a time simultaneously, there is no disturbance will be occurs. Look at this, what are the signals? This is clock signal, this is a gate signal and this is out signal. So clock and gate will be an input and out is an output signal. So what are the pulses to be counted, that clock will be connected here. So look at this is a counter 0, that's why we are taking is a clock 0, gate 0 and out 0. If it is a counter 1, we take is a clock 1, gate 1, out 1. That means each counter have a different signals of clock, gate and out. So this gate will be used to enable or disable the counters. Whenever gate is 0, the counter will not count the clock pulses. So whenever we give a gate is 1, then only the counter will be enabled, then it starts counting the clock pulses. So For example, if you take and counter 1000, so what happens? So the counter starts counting that pulses. So whatever the delay we are deciding, depending upon that, the counter value will be loaded. From that, it will starts incrementing. Whenever there is an overflow, it creates an output pulse that will be sent to this out pin. So this is a counter 0 out pin. Similarly, counter 1 and counter 2 have this out pins. So these clock pulses will be counted depending upon the mode of operation. Once the count is reached, it gives an output pulse corresponding to it. Similarly, if it is used for an internal clock pulses, it will be considered as a timer. If it counts as external pulses, then it will be called as a counter operations. Look at this control word. Look at this first one. This is SC1 and SC0. So this is a select counter. This is RW1 and RW0 read write logics, and this is M0, M1, M2. This is a mode, and this BCD is a binary coded decimal. Whether the value is a BCD or a binary value, that will be decided by this BCD counter. Look at this first one, SC0 and SC1. So 00 means it selected counter 0. 01 means it select counter 0. 00 means counter 0, 01 means counter 1, 10 means counter 2, and 11 means it is then read back command for 8254, and that is not used in 8253. Look at this read write logic. So this is RW0 and RW1. So 00 means counter latch command, and 01 means read write of LSB byte of the data, and 10 means it's an MSB byte of the data. That is a higher byte, this is lower byte. That is 01 is a lower byte and 10 is a higher byte. And 11 is, so it will be used for this. Whenever we read the first time, it gives a lower bit, and whenever we read a second time, it gives an 1 1. So this is the best preference will be used, because whenever we need to read the value in counter, so first we need to load this 0 1 and we need to get a lower byte, and then we need to load a 1 0 and we need to get a higher byte. Instead of that, we can load it a 1 1. So first time whenever we reading, we get a lower byte. Next time whenever we reading, we get a higher byte. So with 1 1 is best suitable to read both bytes. Look at this, is the mode of operation. So 00 means a mode 0, 001 is a mode 1. This is both combination, that is 010 and 110 gives a mode 2 operation. Here 011 and 111. So this is a mode 3 operation. 100 is a mode 4. 101 is a mode 5. So each mode have a different operation. Depending upon our application, we can choose our required mode of operation. Look at this. This is a BCD. If you give 0, it's a binary counter. This is a 16-bit counter. Whenever this is 1, that is a BCD, it acts as an BCD counter. BCD counter means binary coded decimal. It counts from 0 to 9. So after 9, it comes for a 10, 11, 12 like that. But if you take this 0 binary means, so it will be count from 0 to 9. After that, it will be A, B, C, D up to F. After that only it comes 1, 0. Thank you.